Today, I am going to discuss probability rules or the probability more properties about probability laws. Okay, so in the last class we learned probability three probability laws. So here I will recall those things. First one says all probabilities should be between should be greater than or equal 0. So we define the probability function, which is a set of all events in a sample space and goes to real numbers 0 and 1. Here this A is a collection of all events in omega. And with this sense, we define or we talk about three laws about probability function. So with these three laws, the function P become a probability function. Okay, so the first law says if you take any event in this collection of events, A, curly A. Okay, so any event A from this collection of A, PA, the probability of A should be greater than or equal 0. The second rule says the additivity. So you can add the probability of unions. Okay. You can do this one. Okay, so this is A. If A is a pairwise disjoint, and the third property normalization, we say probability of the sample space is going to be 1. So these are the main three rules we learned in the last class, and using these three rules we prove probability of the null set is 1. So this is null set, or the empty set is oops, I'm sorry, here probability of null set is 0. And we did one more thing. If another note, we did if A equal omega 1, omega 2, and so on, then probability of A is probability of omega 1 plus probability of omega 2 and ... Okay. So these are the things we mainly cover in last class, and we learn how to find the probability of an event if outcomes are equally likely. Okay. If outcomes are equally likely, then we can find the probability of an event is number of items in the event over the total number of events in the sample space. So those are the things we cover in last class. Now we are going to use this mainly these three rules to obtain few more properties of the probability laws. Okay, so we are going to derive few results using these three probability laws. Okay, so all these probability properties I will prove, but I'm not going to ask these proofs. Okay, but I'm expecting you to know how to use them. Okay, so if you know how to use those rules, those properties, that's enough. You don't want to know how to prove it, but I will do the proving part as well. Okay, so let's say the first one. So we learned this one in last class. If A and B are two events and if A is a subset of B, okay, so we learned this notation last class under the terminology case. So this is subset notation. A is a subset of B, so that means A is living inside B. Then PA is PA means the probability of likelihood of happening A. Probability of A is less than or equal probability of B. Okay, so if I draw this one, so we draw this one last class as well, but I will draw it again. So this is my omega, and this is event B, and inside event B we have event A. So that's the meaning of a subset. Okay, so then the probability of A must be less than or equals to the probability of B. Okay, so let's see how we can prove this one. Okay, so these proofs are some, there are some format. Okay, so the proof should start with the two disjoint set. Okay, so all proofs, what we are going to discuss today, will start with two or more disjoint sets, and then use the second property to break those probabilities. Okay, now let's see this one. So if this happen, A is a subset of B, and this notation means implies. Okay, so this notation means implies. If A is a subset of B, implies B can be written in this form. Okay, so B can be written in this way. So let's see, is this true or not? Okay, so I'm going to write down B. Okay, so this is omega, and here A, I mean B, here B. B is the larger set. Okay, B is the larger set, and inside B we have A. Okay, so A is a subset of B. Okay, so now we need to write down B in terms of A and B intersection A complement. Okay, so this is my B. Okay, this is B in blue color region. So this is equals. Okay, I'm going to draw it again. This is B. And this is A. A union. So A union means this part. A union with that one again to show the B intersection A complement part. So this is B. Okay, so now I'm going to shade the B intersection A complement part. So B intersection A complement will be outside of A. Okay, A complement means outside of A. Intersection with B means this donut shape part. Okay, so if you combine this this region, the gold color region, and the red color region, you will get entire B. So that's the meaning of this one. And you can see these two sets are disjoint. Okay, so A and B intersection A complement is disjoint. Okay, so now we are going to use the second property of probability loss. Okay, so the second property from second law. Okay, from the second law, we can say probability of B. So if two sets are equal, their probability should be equal. Okay, A union B intersection A complement. Okay, so now I can break this complement, disjoint sets. Okay, so I'm going to write PA plus P B intersection A complement, because these two are disjoint set. Okay, so this because A intersection B intersection A complement. So these two are null set. Okay. So there's no intersection between A and B, A event and B intersection A complement event. Okay, so that's why we have this results. Okay, now, okay, so now we have this step. Okay, so I have repeat this PB equal to this one here. Okay, now see. So PB is equal PA plus something. Okay, so that means definitely PB is less than PA, because if you add something to probability of A, then you will get PB. So that means, so if you drop this part, so that means PB is going to be greater than PA. In other words, you can show this one in a different way. Okay, so there's another way you can show this one. I'm going to bring this PA to this side, P minus P. Oops. Minus PA equals to PB intersection A complement. Okay. So see this one. This is a probability. So this should be definitely greater than or equal 0. So this happened from first law. So from the first law, we know the probability should be always greater than or equal 0. So if right hand side greater than or equal 0 means left hand side also greater than or equal 0. So that implies, or that says, so that means we can say PB minus PA is greater than or equal 0. So now I can bring this PA to other side. That completes the proof. Okay. Okay. Okay, so now using this property, we can obtain one more rule. Okay. Okay, so we complete the proof here. Okay. Now using this property, so here PB is greater than or equal PA, we can obtain these two sub properties, sub results. Okay, so let's see the first one, which is PA intersection V is less than or equals to the minimum of PA plus PA or PB. Okay, so let's denote this one first. Okay. Okay. So I'm going to draw this one. I will draw here. This is event A and B. So this is for any event. Okay. So this is for any event. It doesn't matter if it is inside the subset of A, subset of B. It doesn't matter. So, but we are going to use the previous results. Okay. So here, this is event A and this is event B. Okay. Now, okay. See this one. So intersection is this part. . This is my A. Can you see? A intersection B is a part of A. Is a part of A. So that's mean A, this implies A intersection B is a subset of A. Similarly, we can say A intersection B is a part of B. This implies A intersection B is a subset of P as well. So intersection is going to be a subset of A, and it's going to be a subset of B as well. So from these two results, okay, from this one and this one implies probability of A intersection B. So I will draw this one a little bit far. Okay, I will draw it here. Intersection. And this is A. Okay, so I only draw for A. Okay, so from first point, we can say probability of, from using the previous property, A intersection B is less than or equals to probability of A. And from this one, we can say probability of A intersection B is going to be the less than or equals to probability of P. Okay, so see this argument, okay? So there's some probability, some value here. Okay, we are saying it is less than U1 and we are saying it is less than U2. Some value here. It is less than U1 and it is less than U2. Okay, so that's mean this value here, suppose this is X. X is going to be less than the minimum one. Okay, so we can say, we can pick the minimum one. So then it's going to be definitely less than U2 as well. Now we are going to do something like this. Okay, so that's mean probability of A intersection B is going to be definitely less than or equals to the minimum of PA or PB. Okay, so minimum of these two values. Okay, so PA is a value, okay, and PB is another probability value. Okay, so then the intersection is definitely going to be less than of this minimum of these two. Okay. Using the similar argument, we can prove a maximum bound for the union. Okay, so first I will draw, visualize this argument and then obtain it. This is A, this is B. And I'm going to denote the union now. Red color part is the union. Okay. And now I'm going to show A, only for A, okay. Only I'm going to show you A. So this is A. So the black color area I said is A. Now see these points. First point. A is a part of A union B. So A union B means this entire region. And That means A is a subset of A union B. So that means A is a subset of A union B. This implies from previous property, PA is going to be less than or equals to PA union P B. And similarly, we can say B is a part of A union B. So that means B is a subset of A union B. Now previous property, we can say probability of B is going to be less than or equals to PA union B. Okay, so now see this number line, and we are saying some lower bound. Okay, so we have two lower bounds. So we are saying this value in here, suppose this is x. X is greater than L1 and L is greater than L2. So, but if you don't know the L1, L2 exactly, we can say x is going to be greater than the largest value from L1 and L2. So then it is going to be definitely greater than L1 as well. Okay, so now this argument we can write in this way in the mathematical form. We can say probability of A union B is going to be greater than or equals to the maximum of their bounds. So these are the bounds. This is like L1 and L2. Since we don't know which one is larger, we can say PA, PB. The maximum of these two will be the lower bound of A union B. Okay, so that's how we can derive these results. Okay, so, but I'm repeating, you don't want to memorize how to obtain these results. If you know how to use it, that's more than enough. Okay, so hopefully that makes sense. And if you have any questions, please let me know. And now we can discuss the second property of probability laws. Okay, so as I mentioned earlier, so we are going to start the proof with two disjoint sets. Okay, so let's visualize this one first and fail it first. Okay, so this is for any A and B event. Okay, so any event A and B. So if it is any event A and B, I will draw like this. B, and it says B. Okay, so I'm going to use a black color to denote B. So this area can be obtained by combining or taking the union of these two areas. So let's see. This equals so this is A and this is B. Here AB again. Now I'm going to denote A intersection B, which is this part. Okay, so this is the A intersection B. And I'm going to denote B intersection A complement. B intersection with A complement. So that's mean only this area. Okay, so this part is the B intersection with A complement. And if you see these two areas, okay, so there is no common region. So that's mean if you get the intersection with this one, this one with the second event, this whole event. Okay. Okay, so if you consider this whole event and with the first event, this one, there's no intersection. Okay, so if you get the intersection, these two, it will be null. So that's mean those are disjoint sets. Okay, so if A intersection B, if you take the intersection B A complement. If you take this intersection, it's going to be null set. But if you take union, you will get the entire B. Okay, so now we can use the second property. Now from second property, second law, we can say probability of B equal probability of A intersection B union, oops, B intersection A complement. So I will use different color for this bracket. And this bracket as well. These are the two events and union. Okay, so this probability, we can break it because those are disjoint because of this result. So because of this results, we can break it and write down like this. Okay, and similarly, we can show this results for PA. So that means PA equal PA intersection B plus PA intersection B complement. Okay, so you have to switch this complement to here. That's the only difference from here to here. So that's the proof. Okay, so that's how we can prove these results. Okay, so that's one line actually. Okay, hopefully that makes sense, and we can discuss the third property. Okay, so before prove the third property, I would like to show you why this is true. Okay, so I'm going to show you why this is true. Okay, so this is A and B. Equals okay, so I will shade the region. So A union B is this part. All items in A, B, or A and B. And PA, oops, I forget to mention sets. This is A, B. Okay, so PA is this whole A part. PB means the whole P part. And can you see when you are adding PA and PB, you are adding this intersection part twice. So that's why you have to subtract intersection once. So if you add PA plus BB and subtract the intersection once, then you will get union. Okay, so now let's see how we can prove this one. So we can use, we can write PA union B equal PA plus PA union, A complement intersection B. So we can write A union B has A union A complement intersection B. Using these two events, those are disjoint. Okay. Now let's see this one first. Let's visualize this one first. Okay. So this is A and this is B. So now I'm going to shade the corresponding region. So this is A union B. A union B will give you by A, this is A plus A complement. So A complement means all the things outside of A intersection with B. This part. That's true, okay? So if you add these two regions, you will get A union B. Okay, so now I'm going to take a probability function for both sides. So I'm going to take P A union B equal P A union A complement intersection B. Now, since these two are disjoint, here you can see these two are disjoint. I can write probability of A plus probability of A complement intersection B. This because, okay, so this because A intersection A complement intersection B. These two events are disjoint set. Okay. Now that's how you get this step. Now what I'm going to do is, can you remember in the previous results? In the previous results here, in this results, when you have A complement B, which is same as A complement B here. So P A complement intersection. Okay, I will write down the results first. So if you write down the equation for PB, which is PA intersection B plus PA complement intersection B. This is from second property, okay, not second law, it is second property. Second property of probability laws. Okay, so from this one we can write something like this and bring this one to other side to find the expression for this value. So P A complement intersection B is same as PB minus P A intersection B. Now you can plug this expression instead of this one here. Okay, so that's how you can end up the proof. Okay, so since we have these results from property 2, we can write PB equal PA complement intersection B plus PA intersection B, and then plug it here. So then you ended up with PA union B equal PA plus PB minus PA intersection B. So this is the general addition rule. This is also known as general addition rule. So this is very important, okay? And you must memorize and you should bring this one into your cheat notes, okay? So this is also called general addition rule, okay? So this is true for any two events A and B inside the sample event. Okay, so the last results, the last property. So PA union B is going to be less than or equals to PA plus PB. So this is some results we can obtain from the previous results. Okay. So from the third property of what we discussed here. Okay. So the general addition rule, we can say PA union B is equal PA plus PB minus PA intersection B. And if you drop this part, okay. So if you drop this part, okay. So this is how we can prove this one. So I'm going to bring this one here, PA intersection B is same as probability of A plus probability of B minus probability of A union B. So since this is a probability, this should be greater than or equals 0 from the first law of probability. So that's mean PA plus PB B minus PA union B is greater than or equal 0. Okay. So this the left hand side should be greater than or equal 0, and the right hand side also should be greater than or equal 0. So from this last step, we can obtain the required results. Okay. So this is the fourth property is important when we don't know about the intersection. So if you don't have information about the intersection, or intersection is unknown, then we can find the upper bound of the union. We cannot find exact probability of union, but we can find the upper bound of the upper bound for the probability. Okay, so those are the rules I need to discuss in this class, and I will do 2 examples. Some of the examples we are using this both of these examples we are going to use these properties we learned today. Okay, so let's see the first one. It says PA equal 0.7, PB equal 0.5, and intersection is 0.4. Probability of intersection, we asked to find probability of A union B. So use the general addition rule, which is A union B equal PA plus PB minus PA intersection B. So that's mean PA 0.7, PB 0.5 minus 0.4. So the answer is, you can use your calculators, okay? So the answer is going to be 1.2 minus 0.4, which is 0.8. Okay, so in this case, intersection is given. We can find the answer for A union B. Okay, now let's see the second example. Next example, the intersection is not given. Okay, so we don't have information about the intersection. So in this case, we cannot find exact probability for A union B, but what we can do is we can find the lower and upper limit for A union B. Okay, so see this calculation. Okay, so from the last results, we know A union B is going to be less than or equal PA plus PB. So that's mean PA 0.7, PB 0.2. So PA union B is going to be less than or equals to 0.9. And similarly, we can say we learn probability of A union B is going to be greater than or equals to the maximum of PA PB. Okay, so that's we learn under the first property of law. So the maximum of PA, which is 0.7, PB 0.2. So maximum of this one is 0.7. So that's mean probability of A union B is going to be greater than 0.7. Now combining these two, okay, so combining these two, we can say probability of A union B must be between 0.7 and 0.9. Okay, so this is the lower limit and this is the upper limit. So it should be between 0.7 and 0.9. Okay, so that's the end of this question. So that's how you can answer this type of question if you don't know the, if you don't have information about the intersection. Okay, so that is the end of this video. In next video, I will discuss the concept of conditional probability and independence of two events. Okay, so if you have any question, please send me an email or visit to my office hours. So I'm looking forward to meet you on our fourth video. Okay, thanks for your attention and time. Have a good one.